Hello again, everyone. Welcome back. It's episode 5. Today we talk about selling somebody something they want when they want it and making money doing it. So let's do that. Why not, right? Keep the economy moving. Couple of things before we get started. What's going on campus? We had the career fair yesterday. As I just remarked, if you look at engineering hiring as an indicator, for example, a leading indicator of economic activity, it looked pretty good. Of course, no one was hired yet, but at least the recruiters were out. Definitely saw a few alums. And a number of other folks, some folks in the program were here recruiting. And I guess, let's see, as a result, this morning, if you're a U.S. citizen who can get a security clearance and all that kind of thing, Los Alamos actually gave me some information. So those of you who are interested, let me know. Apparently, they have a group up there that does process modeling and engineering, and they have everything from economists, IEs, systems people, and so forth. So if interested, let me know. And other thing, the Institute of Industrial and Systems Engineer chapter has their welcome meeting. They already socked me for money for pizza. And so go and eat pizza at 5:30 this evening in the student lounge if you're around campus. We haven't quite conquered the internet version of pizza yet, but someday we'll be able to. We used to have jokes about having a graduation through Skype. And we were theorizing how you could do it and have people pretend to walk on stage and things like that. Haven't quite gotten there, and we definitely can't deliver pizza everywhere everyone is when they're watching this show. So we probably could if we spent enough money. Right? But not that we're cheap people. It's more like that's not the purpose of our show. So the rest of you will have to buy your own pizza. But certainly I'd be happy to buy you some if you were on campus. Okay, so today, Chapter 2, a couple of problems quickly. One of them's a little complicated. If you're in class, I have a copy of the spreadsheet with the handouts. If you're not, I'm going to load these spreadsheets that I'll be showing you, and then you'll see where I got the numbers from. Okay? Go through them kind of quick, but you'll have the spreadsheets once I get to load them. This morning was a little hectic in Chateau IE, so I didn't get to load them yet. There was some innate demand from NMSU institutional headquarters, and because of career fair, people were wandering in and that kind of thing. So I'll get to it. All right, any event, today we're going to talk about planning for sales and operations, your supply chain, and you. Where does this stuff come from? The answer, of course, Mom. Right? Or maybe our friend Grandma from my other class. Okay, so we started on number 17 last time. Look how big I got those numbers, huh? That's great. Number 17 was a forecasting deal with a Where are you, number 17? Thought I had it. My book is, the binding is cracking, so it's a quality issue. It's not a lifetime textbook. Okay, page 69. Number 17, 16, and so forth. This just shows you the 1 month ahead and the 2 month ahead forecast for July through December. These, you'll recall, were the actuals, right? I would, in fact, be suspicious of anyone foolish enough to have error terms of 0. All right? Nobody's that good. I don't care where they went to school. Nobody is good enough to get a whole year forecast right. Okay, anyone has zeros for the errors, you should worry. Alternatively, I could teach you how to cheat on that. Right? What would you do? You would retroactively change your forecast, right? We'll leave that to the realm of political operatives, okay? Because this is, in theory, this is real, right? This is a part that there's a demand for. For example, car batteries, oil filters. If you bring your Lamborghini over to the local oil change place, the chances are they don't have the filter in stock, right? Might want to buy a few, keep them around. Okay, so in any event, 1 month ahead means you go back however many months and forecast from 1 month ahead. 2 months ahead means there's an extra block empty. So for example, in the problem 18, it says the 2-step ahead is February through May for July. Whereas you would need numbers through June to forecast July with 1 month ahead. Now, what's the problem with that 1 month ahead deal? Why would anybody go to 2 months ahead? Well, oddly enough, just like you guys, the people who generate forecasts have trouble getting data on time. Maybe they need a month. The ending data for June is available when? June 30th, right? Close of business. What good is a forecast for July on July 1st? Not super helpful. So you would need potentially to consider more periods ahead. Now, if this is a mission-critical piece of hardware, you would plan differently than if this was a number 6 machine screw, right? That's the only thing to think about there. The error terms are calculated just like in the textbook. This is just to show you. Notice the error on average in the 2 month ahead is kind of bigger. Not always, but this would be more interesting. Of course, you plot these things and look at them, and easy to do. But for our purposes here, this was convenient. The other problem I wanted to talk about briefly is problem 53 in the back of the chapter. This is Baby It's You, which I know that one author's a musician and all, but title of that firm, definitely a little weak, right? Baby It's You makes baby food, and oddly enough, they've discovered a correlation between sales of baby food and number of births. This apparently required extensive research, right? More babies, more baby food. Sounds like you could take that one to, you wouldn't need Brad Pitt and George Clooney for this operation, would you? I guess they're making another Ocean's movie too, by the way, with all women characters. So, amazing what happens while I'm talking, right? But you certainly don't need Las Vegas to figure this relationship, right? Nothing sophisticated about this. So they give you some data, and they ask you to develop a regression equation based on years 2 through 8. And they say, hint, you will need the general regression formulas in the back appendix. Yes, you do. Because actually, I didn't believe their hint and just plotted a general linear model on these data and got nothing like their answers. I said, geez, I wonder what happened. I probably loaded the data wrong, actually, but more seriously, I went back and did a spreadsheet based on, and you guys have this one. But the thing you have to do, and this is perfect to do in Excel, by the way, is get sums of columns and square items in columns and things like that. And you end up getting, for example, what they call y sub I and x sub I, which are sums. And then you get an sigma xy, sigma x squared, and so forth. And you calculate n is 7, by the way. I'm trying to fence that off because that's the other part of the problem. And then you get an SXX and that ends up equaling 10.56. And you calculate a line, the B in the line and you can solve for A, which ends up being minus 5.75. So YT minus 5.75 minus 4.16, and then you get x bar is 23.7 over 7. And all of a sudden, you know that yt equals a is a negative, so in this case, the xt sub I minus 1, you get the forecasted births from the chapter, from the question. You plug that in, and you get, they should make about 800 grand selling baby food. So what you got to do is take a look at Appendix 2 of the chapter, and that'll sort of reveal all the equations and everything. So essentially, why would anyone be interested in the answer to that question? The answer is, of course, what might we do for our factory? Should we expand? Should we invest in spare parts? Should we hire more people? If more babies are coming, that tends to suggest more baby food. Will that generate enough revenue to buy more machines, to give everyone a raise, and so forth? Now, the other part of the problem that I did this fenced off area here, and that's just the part where you do the exponential smoothing. You take the first 4 months, you get an average of 3,225. That's the moving average, and then you start forecasting. And you'll notice that the actual births versus the forecasted births, you're not exactly hitting those out of the park, are you, with these numbers? In theory, if I used this model, I was wrong, 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 who knows? Not me personally, but the character who said forecast it this way. Okay, so I'll load the spreadsheet when I get a chance. You can screw around with it and see how I did it so that everybody gets the idea. So that's baby, it's you. And again, the point of a problem like this is not necessarily get the correct answer, it's get the correct answer and the correct decision. New Mexico State University is currently having agita as a result of an apparent unwillingness to look at forecasts. The agita goes something like this. Over the last few years, it has been commonly known that the number of high school graduates in New Mexico has been dropping. Now, the number of people who could graduate from high school is quite different from the number of people who do, but we're not teaching high school ed here, so we'll leave that alone. But think about it this way. If there aren't more freshmen, then what should we be doing? Answer, potentially we either need to find another market, or B, consider contracting, or C, do something else, right? Well, apparently what happened is not much, because there's lots of weeping and gnashing of teeth and such going on around campus. But think about it. If there are more high school graduates, then more people go to college, right? Unless we believe Mike Rowe, who has his website and all that. Mike Rowe, the guy from the Discovery Channel, the Dirty Jobs and the crab fishing announcer and all, he believes in more of an apprenticeship type program. He's been testifying to Congress about things like that. Oddly enough, Mike Rowe has exactly the degree he makes fun of, which is a bachelor's in communications from Towson State in Maryland, but maybe that's why, right? Who knows? But he thinks people shouldn't necessarily go to college, they should do apprenticeships. And that's become kind of popular in some states. Those of you in our audience who are in the military, if you've been in the Carolinas, they have the influence of the German auto manufacturing. And the apprenticeship thing has become more interesting. So why talk about this? What does somebody do with a forecast? They have a forecast. Maybe they do nothing. Maybe they do something. Maybe they do the wrong thing. Almost always doing nothing is not a viable alternative in many environments, but knowing what to do is a skill. And no matter what comes out of this, and the reason why I make fun of the numbers being wrong here is not that I think the guy who invented the idea of 0.15 on alpha is a bad forecaster. It's that the results are not so good, right? If I actually encounter, after forecasting births of 3.2 million, if I encounter 3.8 million, that's 600,000 babies that are not getting our brand of food, potentially. Or worse yet, I incur additional costs running overtime shifts, right, to keep up with demand. What might I want to be doing at that point? Take another look at my forecast, see how to improve it. Now, obviously, it's a homework problem. It's not real, but that's what a real person would do, is they'd have to go look at why was I wrong by 600,000. That's a lot, right? And the potential costs of that are quite significant. Okay, so enough of forecasting. If you get interested in this stuff, there are classes around campus, certainly. We don't teach a lot of it in IE, but there are some classes around. And you can get all the way into ARIMA forecasting and that sort of thing. We didn't talk about autoregressive integrated moving average, mostly because the situations where that kind of forecasting is helpful are not common in what we're doing here. The textbook, being a sort of broad spectrum textbook, has some minimal coverage, enough to be dangerous. So instead we'll just know that you could take a class and leave it at that. So let's talk about logistics, a point of interest to many clients of this class. Right thing, right place, right time, right condition. The big deal here is what's the contribution to the firm, the organization, and so forth. I had a young man in my office this morning who has some interest in what's called humanitarian logistics. That's how do you deal with situations that are not, shall we say, the norm, you would hope. International type situations where countries have disasters or some other type of thing where you need to crop failure, even down to, I mentioned, pre-positioning bottled water. That has a humanitarian component. The contribution to the firm is important. The company, if you will, is essentially how do I get the product to the customer when they want it. Like my example last week of having a Western Conference Championship t-shirt delivered 2 weeks after your team lost in the next game, somehow it isn't as much fun to wear it, is it? Timing, right? A couple of years ago, it happened that there was a weather front that went through Kentucky and Tennessee around December 23rd that screwed up the airports in Louisville and Memphis, which should ring a bell with all good IE students because Louisville is UPS's main hub, as is Memphis for FedEx. If you had ordered something to be overnighted in time for Christmas Day, the chance that your family member didn't get the box on time was fairly significant. Now, what was interesting is it made news because a lot of people complained, right? It always makes news when the Louisville or Memphis take a weather hit because of the size of those hubs for delivering stuff. And because it was Christmas, that was even more of a good story, right? Because what better to write about than unhappiness? And it's not an interesting story if everyone gets their present on time, right? Well, any event, I was fascinated by the number of people who were outraged, unbelievably so. I thought maybe they paid someone to say these things. You may have noticed right around December 24th, you may have gotten an email from a company that assured you you could still get a gift there on Christmas Day by buying an emailed gift card. That's an attempt to respond to those kinds of things, or forgetting, or whatever. So getting this stuff there is important in the sense that it has to be there for people to buy it. So we talk about the concept of supply chain in here, and the important thing is how do you get your product to the person who consumes it? Raw materials through delivery. 1,000 years ago, if you wanted to study in college, what did you do? I can tell no one in here took that class. Everyone's staring at me. Well, what would you do? You got on your whatever method of travel you could find and traveled to the town where there was a school, right? Now you want to watch the Dr. Pine show, you could be anywhere, right? We've had people in Afghanistan or Iraq, all sorts of places taking class. Not as in, we don't normally distribute outside the U.S., but people in the U.S. military or contractors, they're all over the world. Korea, right? You don't have to get on a plane and come to Las Cruces. You can watch me on the internet, right? What's the difference? The technology to deliver it, right? Kind of like until the mid-1800s, there weren't really stores. Not the concept you have, certainly. If you needed clothing, you had to make it, and so forth. So we're a lot further, is the point, from the raw materials than we used to be. Cotton's grown in West Texas, gets shipped somewhere, gets dealt with, gets shipped somewhere else, gets dealt with. Eventually it goes to the local Macy's or Kohl's or what have you, and you pull out your Model X off the shelf, say, this is the size I bought last time, why can't I button it? Essentially, how do you control that chain is what we're going to talk about. And how do you look at performance? Like vendors, how do you perform as well? I buy something from you, do you deliver on time? Does it work? And so forth. We start with the customer and go backwards. What do they want? I get into this all the time. We talk about distance ed. I said, who are the customers? Somebody says, what? We want to teach XYZ degree. And I said, well, but who are the people who are going to watch this show? Where are they? What do they want? Do they want that? Well, they should. I said, that's a guarantee of disaster, right? Who knows? You have to go, essentially, my friends in the MBA program would say you need a marketing study, right? What do people want? What kind of service do they want? Where might they be in the market? Why, for example, is there no Mercedes dealer in Las Cruces? Not enough market segment, and plenty of people driving them around here, but not enough people who would support a dealership potentially. How do you meet what they want? I can tell you that when Amazon first came about, there were people who didn't believe it would work. Right? Most of the viewing audience is not old enough to remember that. But the idea of buying books, the way you buy books, really is a relatively recent thing. The idea of get online and point and click, it's only 20 years old or so. It seems perfectly normal. You can't imagine life without it, right? How do people measure your performance? And for those of you who like this kind of thing, the good Dr. Kaplan from Harvard created the famous scorecard. And this one's been all over. It looks like that. How do I align what I do with what the customer wants? How do I deliver what they want? That kind of thing. So check out the graphic on page 135. That was the one on 133, 135, same idea. Check it out when you get a chance. Read this part, it's important. What do we have to be good at? How do customers see us? How do we look to whomever? I famously got a lot of grief a couple of years ago with one dean or another because he was concerned about scoring the IE department. And I said, excellent. What are you going to do about it? And he just sort of looked at me. I said, before you keep score, I want to know, are you going to help me fix anything? Because if not, you're just going to be annoying. And basically, you guys are already demanding things that can't happen. Why should I give you a scorecard to do that? So what you want to think about when you think scorecard is not just scorecard, but what's going to happen if you find something out you don't like. If it isn't good enough, how are you going to fix it? Now, it sounds funny when I tell a story, right? But realistically, think about it. If, say, for example, a lot of the undergrads who are taking this class are taking an online version because they have a conflict with ie524, right? And a few people were giving me a hard time, and I said, you know what? Maybe I shouldn't let you take it online. And they said, it'll take me an extra year to graduate. And I said, sounds like your problem. You're taking a freshman class and a senior class in the same year. That's not the way the program works. People looking at me. I said, before you start scoring things, you got to make sure you understand what you're scoring. Right? If you're looking at a scorecard, what you got to do is be able to do what? Fix something you don't like. One famous example came, the NMSU Strategic Planning Peer Group is well known. And one day I pointed out that the names of the schools, the average size of the IE department in any of the peer schools was quite a bit bigger than the one here. I said, therefore, you should be before you measure, you should invest accordingly. And of course, I got told to go back to my office and think about my sins. But realistically, why would you compare 6 people? We had 5 people at the time, with somebody who has 18 faculty, right? You're going to be disappointed, right? What are you going to do? Say, wow, those 6 people are doing 1/3 of what 18 can do. So think about it as you think about scorecard. It isn't just a fancy graphic, it's real people doing real things. We talk often about the idea of key performance indicators. And if you're a reader of the NMSU strategic plan, you've seen that KPI term. It comes from Kaplan. They didn't invent it. Usually in the IE department, we're thinking about efficiency, time, cost and materials. People are in cost, right? That kind of thing. But when we think about quality, we think, what does the customer want? How do they get what they want? They complain about it, do they do whatever? So when we think about our supply chain, this is from the textbook. Routine variation is nice. In quality control, if you took 365 or 571, then you've heard the term a system of chance causes or common causes. This is ideal, routine variation. Things I can plan for, the known unknowns, in the sort of oddball speak of planners. The unknown unknowns. And my personal favorite, chaos. Everything is at risk. When you think about plans, when I said, for example, how are you going to measure something that's not the same thing, i.e. Department 1 and 2, the presumption in that was that both systems were operating here, when in fact we actually pretty much most of the time are operating here and here. It's kind of interesting, huh? So once in a while someone will come in and say, why didn't you think of this? And I say, excellent. Get out your crystal ball and tell me what will happen tomorrow when you're thinking about your plan. And the point is, there are things we know we can plan for, and there are things that just happen. There's a lot of those things out there. And if you're making a product for someone, there's all kinds of things that can happen. Some you can plan for, and some you can't. You can plan for the weather to be bad on December 23rd. Correct? One thing you might do is advertise and tell your customers order early. And in fact, those of you who use the internet for shopping probably noticed that the companies were saying last day to order by ground, last day to order by air, that kind of thing. That's an attempt to deal with this. We know weather could be bad. We know it takes time, therefore act accordingly. Now, many people who hear me say this say, duh, what's the big deal in that? And I say, well, read the business section of the newspaper or Business Week and you'll find out. There's all kinds of people out there who didn't plan correctly, or didn't plan to meet things they didn't know would happen. Recently, over the last few years, to give you an example, the idea of sustainability has become important on campus. Recycling, right? Interesting problem. Recycling of plastics at the moment is not as profitable as it was when gas was $4 a gallon. A whole lot of people who believe in recycling never considered that the market for petroleum products could go. So the whole supply chain that deals with recycling got a little perturbated, because what do you do with this stuff if it costs you more to recycle it and make a new product than it costs with the old stuff, the fossil fuels, right? So there's an example from real life. Now I'm going to introduce a concept that's important with planning. And these terms have the highly scientific names of frozen, slushy, and liquid, if you like. Typically, people talk about a time fence in this system. In the frozen period, there are no changes. Intermediate term could be 6 to 9 months, 12 months out. Potentially, it depends, and maybe you could change something. Liquid, over a year out, 3 to 5 years. If you have to build a building to do something, liquid planning is important, because you're not going to build a building in 90 days. Well, you could, right? Metal building? Have it up in no time? Depends on the kind of building you want, right? Which tells me that if I can use metal buildings, then my time fences change in length. And information generated from data is an important concept. There's a data point I refer to frequently in classes and in conversation. It refers to this thing. In the movie, this is Spinal Tap. There's some discussion. When you buy an amplifier for a guitar, the fake interview is with the guitarist. And he has a Marshall stack. And normally they go, you turn it on, and the amount of volume you get goes from 1 to 10. Well, his was custom made to go to 11. And Rob Reiner is trying to figure out what's going on. He says, what do you mean 11? And he says, mine goes to 11. That's an interesting use of data to me. I love that. Probably because at the time I saw the movie when it first came out, and it was really funny. It made fun of the expensive rock band persona, right? The guy's thing went to 11. We get data from somewhere, right? And we turn it into information. Getting people to agree on what data gives us information can be a coordination problem. Another example I use right now, most days of the week I get an email from institutional research. It tells me how many freshman candidates have applied. That piece of data is important to many people. It's not important to me. And you'd say, geez, that should be important. And I said, well, most people don't choose IE as freshmen. So if we get 5 people to apply as brand new freshmen during the year, that's a big deal. That's like, wow, a banner year. I said, I can show you whole semesters of graduates where not one of them started with us as a freshman. It's not good or bad or indifferent, it's just data that, to me, is not what? Informative. How do I coordinate getting people to agree on what's important? Right now, the university business is changing quite a bit. There's a lot of people using these types of data to study how people perform in school, to see if they can infer things about students to try to help students get through college. It's a good thing, right? I went to a presentation on it. Unfortunately, at the level of the presentation, I discovered that if you take 4 years of math in high school and do well in Calc 1 and Calc 2, you might probably graduate in engineering, is not super useful data for me. I already know that. On the other hand, not all majors are as well defined. So for some people, it may be that a grade of C in Accounting 252 might suggest alternatives to accounting as a career. That's still a little, but you can picture in some majors that might be useful stuff. I know that when I was in high school, I talked to one school and they said, what was your grade in geometry? And then they said, don't apply. Okay. You weren't likely to make it here. Great. I tell that to every kid who went there, who comes to grad school. I tell that story. I said, there's your predictor, right? Maybe it was right for them, not right where I went, or whatever. But how people draw information from data points is pretty important, as you'll see through the semester. Like even our forecast. You notice how I could make up all those stories about the little baby forecast, the baby food forecast? Well, 5 people can look at that problem and generate, if they got to generate pretty much the same understanding, or you're going to have a headache. Some terminology that will be useful if you get an interview. Core competencies. It's one of my personal favorites when this came out. I like rhetoric, so whenever people come out with rhetoric for business, I always laugh. In other words, things you're good at. What your business is good at. The core might be the key things you do. How well does the firm integrate? Walk around NMSU and see how well we are integrated to function. Flexibility, agile. Another one that comes up around here is the agile organization. So, all good things, great to talk about in interviews. Agile processes. And I always say, as opposed to like what? Ones that don't work, which seems to clunk occasionally. But the idea of agility is the ability to change to meet customer demands. Some decisions based on our forecast. Do we make things or buy them? What do I keep around? In other words, inventory policies. How many boxes of cereal should be in the closet, for example? It's an inventory policy. Of course, it tends to ruin your sense of going to the supermarket, doesn't it? It's just like clunks, as I say. How do we produce things? Do we make a lot? Do we make a little? What do our facilities look like? So those of you who are undergrads, if you're taking Dr. Vyas's facilities planning course, how big should the entity be? Example, and you can use this for anything. How big, if those of you who live in Las Cruces, or wherever you live, how big is the hospital where you live? What sort of features do they have? Those are all the results of somebody doing some forecasting. How many customers could we expect? What types of specialties should we support? It could even go down to something like doctors in a specialty. How many can the town support, for example? So all of this can be applied a lot of places. What's my workforce look like? One thing I've known since I was in grad school, to my great surprise actually, was we produce more PhDs than the faculty market can absorb. Schools produce a whole lot of PhDs. Not all of them can get academic jobs. In some fields, it's quite horrendous. In others, like IE, it's got its ups and downs. What kind of workforce do I need? And actually, oddly enough, for universities, producing more PhDs is a good thing, regardless of the future for said PhDs. And it's actually cheaper to run the place with all people who are non-tenure track, adjunct type people. By the way, that's not a good policy would be a mix, right? A less good policy would be all people who are not really here, work 4 places to make a living. What kind of workforce do I need? Is something that relates to how well I can serve my customers. We also talk about support activities, materials. How do we move them? Where do we keep them? How do we buy them? When we warehouse things, we incur the cost of the warehouse plus the cost of all the other stuff that goes with the warehouse. Security, shelf life, all that kind of thing. Then how do we move things? Move it by railroad, ship, truck, pipeline. How do you move the thing you sell? If you move the thing by truck, you have different issues than if you move it by railroad, airplane, what have you. I was looking at a product this morning that cannot be shipped by air. What do you think it was? Just test. Come on, quick survey.
Something battery related?
A battery? Not even a battery. Hand cleaner. Alcohol, sanitizer type stuff. This was a shall we say, a higher end version of the thing that's all over. But it clearly stated, cannot be shipped by air. It's got alcohol in it. It's a fire hazard, right? Batteries are, get on a plane, you get a speech about whether you have a Samsung, whatever. I'm trying to think of who isn't aware of that by now, right? Every time I hear that speech. So again, how do we route things and schedule them? How do we move them both in plant and externally? The number of people who borrow, we have a leftover hand truck in the IE office for moving boxes. The number of people who borrow it are nice people, usually grateful. We bought it, I don't know how many years ago, 20, 25 years ago. It's still sitting there. Does good deeds, right? Somebody needs one, it's perfect. If you don't have one, you're carrying a box at a time. Takes you 3 times as long. The logic is true no matter how unsophisticated or sophisticated. Getting stuff to the place where you do something to it can be expensive. Actually, if you think about this, think about how manufacturing occurs across the U.S. Why do you hear the term Rust Belt still? Those places have all changed. But it had to do originally with transportation, because you could transport stuff on the Great Lakes. And again, when you think about this stuff, the logic I learned so many years ago, it's hard to get rich playing someone else's game, which we'll find out this weekend from the Super Bowl. I should have run a pool, right? Forecast the points. Then we could have checked variance and, oh well. What game do you play? What does the market want? Notice how the discussions about electric vehicles, such as once you got past the Prius, the more expensive thing that's floating around out there, the one that Elon Musk, Tesla, right? There's a whole bunch of people that didn't think he'd do it because he wasn't a car manufacturer. Like somehow you can't hire engineers who worked in those places, right? Got a plant going in Nevada. Does the market support this? We have yet to see, but certainly there's a lot of people that think that is one cool looking car, right? They just don't happen to have that size budget yet. So the idea of core competencies becomes important. What do you do well, and what do other people do well? who can you get as a partner or supplier to your business? For example, batteries. Would you want to make your own batteries for a product? No. Why? You can buy them. I have senior design groups all the time that are making things, and I'm looking at them. I said, why don't you just buy one? And they said, we thought we had to make it all. I said, you don't think GM makes that, do you? Why would you? What do you do? What do other people do? These are decisions you can make. When we talk about that, what we will do is look at cost. Think about it. If I forecast making baby food or what have you, nose spray, popular product around Las Cruces, 370 days a year. People have all sorts of nose sprays, right? You could make your own. In fact, you could do a pretty good job with a neti pot and some warm water. Wouldn't look all that attractive on the street, would it? Not very convenient. So what do people have? Little bottles of saline. You don't think Albertsons or Walgreens makes those, do you? They buy them. Same idea. I mean, yeah, you could wander around, but some years ago we were theorizing a bunny suit kind of thing with a helmet that would have, it was one day when everyone was getting over sinus infections, that would have warm saline running through your sinuses 24/7. And, you know, it was fun to think about because everyone was mad because they were sick of taking antibiotics and nose sprays and stuff from sinus infections, but it's not practical, right? On the other hand, some things are. And what you're looking at is cost, the availability of the technology. For example, batteries. On my desk, I have a battery from an old NiCad analog phone. Man, you hit someone with that, they're going to feel it. That's a big battery. Now, batteries are small. The power density is improved, right? But maybe not enough. The support for the technology, 3D printers are great things. Problem, they also need a lot of support. Where does the revenue come from? Do people buy the thing? Do they buy sales contracts? Do they buy, what are they buying? Because where my revenue comes from, to some extent, drives how I do what I do. How do I get revenue? What do people buy? And also it helps if you actually know how to do the thing. So experience is important. Good idea to sort of have done it before. But imagine you came up with the idea for some kind of electric car. And let's say you could get financing behind you when you were ready to go into business. One of the things that you might be thinking about here is the battery. Where does it come from? Who are the suppliers? Also, in many businesses, you need to know who else they supply. And the obvious answer to that is if they're also supplying giant company A and B, are you an important part of their business? You know that feeling you get when you walk into a store and can't find anyone to wait on you? That's the corporate version. You know, like you can't find an open cash register and nobody knows which of these things you should buy. Why couldn't that happen to you if you were a corporate entity, right? You've got to be dealing with that. So not only, like I say, you do this forecast, but now you're thinking all the way down the road with the forecast. Am I going to be able to get enough batteries? Where do the tires come from? Where are the locks for the ignition? Am I making those? Now, realistically, I'm just throwing things out to sort of muddy the waters. But there is a discipline to how you do this, and that's what we're going to go through. Example. Nice college example. If you guys want to take, say you're a freshman, you need to take calculus, Calc 1, right? Do you see me teaching Calc 1? No, right? What do I say? Somebody says, how come you don't teach calculus? I say, well, you know, we're a specialization of labor kind of people. I said, I got C's in calculus and was glad to get them. He said, you need to take calculus from somebody who likes it and teaches it. And I said, where do I find that? And I said, that you have to ask your friends who to take it from. And he said, because we're not allowed to recommend people. But think about it. You come to the IE department, we teach IE courses, right? Same idea. We don't teach thermodynamics. Somebody asked me once, I explained why IEs take material science, and they said, well, why don't you teach it? You seem like you know more about it. And I said, well, we're like a union shop. We don't cross craft lines. He said, I don't teach over there, they don't teach over here. And the person got the point at the time, but it's the same idea here. The reason is that it's not economical to have everybody in every department. It doesn't make sense. The last thing to close up with, just to show you I'm a modern kind of guy, in the days of the internet, there were people theorizing you'd be able to buy cars that required no big manufacturing facility, like final assembly plant back in the day. I haven't seen that yet. I thought it was funny at the time, because I said the whole system is set up for there to be some final assembly plant. Why would you offload that to someone you're not controlling? Which is, we can talk more about that. There are firms that do custom manufacturing. You can coordinate some things just like eBay over the internet. Get people to bid on making your parts. And of course, another favorite of college professors, everyone will have 3D in their house, and they won't buy any parts. That I'm not sure is coming in my lifetime, or yours, or anything else. Some things just don't lend themselves to that. Some things are more economical, made out of metal or plastic or what have you. But yes, these are all things we could think about. Why have a big final assembly plant? Could we coordinate it better to deliver a better product to the customer? And with that, I'm afraid I am out of time. I will see you next time, and we'll know who won the Super Bowl then, huh? Have a good day, everyone.